Okay, so this one another example. Okay, so let's say we have the fxy equal to 4 minus x squared minus y squared. Okay, so the square root of everything here. Okay, so we know that our dependent variable here is x and y. Our independent variable here is z. Okay, which is z is equal to fxy. Okay, alright, so now want to determine the domain. Okay, so if we want to determine the domain, we need to look at the restriction. Okay, so what's the restriction here? Since it's the square root, so we know that 4 minus x squared minus y squared greater or equal to 0, of course, for this. Okay, so or we can write it as 4 minus x squared plus y squared. So it's easier for us to see the pattern. Okay, so leave it here. So will be greater equal to minus 4. So x squared plus y squared less or equal to 4. Okay, so from here we can say that our domain is xy dependent is x squared plus y squared less or equal to 4. That is our domain. Okay, so how we want to sketch the domain? Okay, so we know that this is circle, alright, with the center of 0, 0 and the radius of 2. So it can be 2 minus 2 minus 2, 2. Okay, so now since it is x squared plus y squared is less than, so it's obvious, so we can just find the domain which is less than 4. Okay, so the radius that less than 2 lah in this case, because 4 is 2 squared. Okay, so now we want to find the range. Okay, so for the range, okay, so it's obvious that we know that x squared plus y squared 4, and we know that it is greater or equal to 0, because we know that when x squared plus y squared is always positive and the minimum value will be 0. Okay, therefore what we can do here is z equal to, so let's say we choose the maximum point as 4. Okay, so for 4 when we choose x squared plus y squared, the maximum point is 4. Okay, for this case, so we know that z, okay, so this one we can write it as 4 minus x squared plus y squared, so make it easier for us, right? Okay, so 4 minus 4, okay, so it will be 0. That is the value, okay, for the minimum point of z. Okay, so if we take the x squared plus y squared, the minimum point is 0, right? So for this case, z is equal to 4 minus 0, right? So it will be 4, which is 2, so 2. Therefore, what we can say here is range, okay, range which is denoted as RF, so equal to z, such that z is between 0 and 2. Okay, so this is the value for our range. Okay.